Inductive and deductive reasoning. These are the two topics we're going to discuss in this section. We try to understand and use inductive reasoning and deductive reasoning. So the question is, what is inductive reasoning? The process of arriving at a general conclusion based on observation of specific examples. So the meaning is, let's say you have some specific example and you would like to generalize from those example. That's called inductive reasoning. Let's say I'm going to give you examples, but before that, based on examples, sometimes we make some kind of hypothesis, conjecture. Conjecture hypothesis means it's just we think that's true in general. So that's called conjecture hypothesis. The conclusion formed as a result of inductive reasoning, which may or may not be true. So just by looking some examples, if we try to form some kind of hypothesis, conclusion, that might be true, may not be true. So how do you know that might not be true? By finding the counter example. If you have some counter example which is not true, then we can say that, hey, our hypothesis was wrong. I will go over some strong inductive argument and then some weak inductive argument. Let's say in a random sample of 380,000 students from 772 four-year colleges, 25% said they frequently came to class without completing readings or assignment. So this is the data we collected, and we form some kind of hypothesis. So we can conclude that there is a 95% probability that between 24.84% and 25.25% of all college freshmen frequently come to class unprepared. This type of hypothesis coming from the random data is very strong inductive argument. That's supposed to be mostly true because we have some kind of confidence level. This technique is called random sampling, which we're going to see in detail in future chapters. Each member of the group has an equal chance of being chosen if it's random. And then based on that, we can make prediction. So this type of, if we make prediction based on the data, random sampling, that's the strong inductive argument. And then weak inductive argument, for example, neither my dad nor my boyfriend ever cried in front of me. Neither my dad nor my boyfriend. And based on that observation, someone is making assumption or a hypothesis, therefore men have difficulty expressing their feelings. So that hypothesis, that conjecture hypothesis is only based on two different people. So this type of conclusion is an inductive argument, but it's a very weak conclusion. This sample is neither random nor large enough to represent all men. So, based on some specific example, if we make conclusion, that's called inductive reasoning, and sometimes that might be very strong or may not be very strong. Let's look at some example from homework. Fill in the blank so that the resulting statement is true. Arriving at a specific conclusion from one or more general statement is called inductive reasoning. That's the definition of inductive. Arriving at a specific conclusion from one or more general statement. It's opposite. It's opposite of inductive reasoning, and there is a special name for that. I did not cover that thing, so let me go over that first, and then we'll go over that example one more time. Like inductive reasoning is coming from some specific example to the generalization, and the opposite of that, which is deductive reasoning, we use the general finding, general observation, and from the general rule we try to apply that to specific example. That's the deductive reasoning. Deductive reasoning is the process of proving a specific conclusion from one or more general statement. So you try to use general statement for a specific conclusion. That's called deductive reasoning. A conclusion that is proved to be true by deductive reasoning is called theorem. So that's the reason the example I was doing here was wrong, because I did not look at this definition before doing this example. So let's go back and then read it again. Arriving at a specific conclusion from one or more general statement. That is actually a definition of deductive reasoning. Arriving at a specific conclusion from one or more general statement is actually definition of deductive reasoning. Let's go to the next problem. Which reasoning process? So in this section we just discussed two different type of reasoning process, inductive and deductive. Inductive means from a specific example we try to generalize it, and for deductive reasoning, from generalized one or two statement we try to apply that in a specific reasoning. We examine the social security numbers of 500 people. No two individuals from this group of people have identical social security number. We conclude that for all people, no two people have the identical social security number. So it's coming from examples to generalization. That's why it's called inductive reasoning. Let's go to the next problem. Find a counterexample to show that the following statement is false. If a number is added to itself, the sum is greater than the original number. So this is the statement. Counterexample means we try to find an example which is opposite to this statement. So we have to find a number, if we add to itself, that's sum or addition supposed to be less than the number itself. So by going here, look at here, if I add a -3 and -3, the sum would be -6, and -6 is less than -3. So this is the counterexample for this statement. Let's go to next example. Look at the pattern here, 1, 1 over 3, 1 over 9, 1 over 27. These are some specific examples. We would like to use these examples to predict the next one. The next number, as you can see here, each number you can find by multiplying the denominator by 3, the bottom number. So the next number would be 27 times 3 on the bottom part. So 1 over 81, because 27 times 3 is 81. Okay, sometime we have to predict by by looking the pattern. So here you can see square, triangle, another is square with the hole, triangle, square, triangle. So what comes after that? It's a square, triangle, and a square with the hole. This one. Okay, identify the reasoning process, induction or deduction. So we have given some scenario, we need to find out either it's induction or deduction. Explain your answer. The data in the graph are from a random sample of a 1200 full-time 4-year undergraduate college student. So based on this data, we have this bars, as you can see here, out of 1200, alcohol abuse, this is the 20%, cost of education, that's less than 20%, and then similar to rest of the category. Based on random sample of 1200 full-time 4-year undergraduate college student on 100 campuses, the bar chart, these are the called this picture, they are called bar chart, shows the percentage of students identifying the greatest problem on campus. We can conclude that there is a high probability that approximately 22% of the full-time 4-year college students believe that lack of the financial aid is the greatest problem on campus. So lack of the financial aid is D, which is more than 20%. So that's coming from the random sampling process, and this is called induction, because from some specific example we are making the conclusion. So what is the correct option? This is an example of inductive reasoning because a specific conclusion is reached. No. This is the example of inductive reasoning because a general conclusion is reached based on a specific example. So this is the right answer. And very last question. Determine whether the following statement makes sense or does not make sense and explain your reasoning. Additional information may strengthen or weaken the probability of some inductive argument. That is right, because inductive argument means it's always we try to generalize things from a specific example. If we add more information, our argument might strengthen or weaken. That's true. So the statement makes sense. There are two options, A or C. We have to read first one. The statement makes sense because an inductive argument is not at an inductive conclusion. C is the statement makes sense because one can never be absolutely certain that the conclusion of an inductive argument are true. This is the right option, because induction means just based on some specific example we try to make a conclusion which might not be true. Perfect. So that's the that's all for this section.